Alright, what's good, y'all? Day 191, I think. Something like that. Almost 200 days. Yeah, let's keep going. Yeah, oh man, we got hard today, so I'm probably gonna die. Let's get to it though. Yada yada yada. So we got here, the median is the middle value in an ordered integer list. If the size of the list is even, then there's no middle value, so the median is the mean of two middle values. Okay. For example, we could do like size of the list divided by integer division by 2, and we will get 1. Right, so this is even. You're given an integer array nums and an integer k. There is a sliding window of size k, which is moving from the very left of the array to the very right. You can only see k numbers in the window. Each time the sliding window moves to one position, moves right by one position. Okay. Return the median array for each window in the original array. Answers. Oh, this doesn't. Wait. This doesn't seem terrible. Except my initial solution was you just calculate each median every time, but that is kind of expensive, right? So we can calculate it once and add and remove as we move our window, right? So yeah. So obviously we'll have a result. So yeah, my idea is like at K, slot K, right? Yeah, that is a problem. I do need to make a copy. That's the only problem. I would like to have like a running total of every subarray, right? And then add and remove accordingly, right? Because I feel like if I make a copy of the subarray, that's gonna be kind of memory inefficient. So let's see how we can do that. So we can go from we can start K here and then move to the right. Or okay, the problem is I need to know the first three values. So nums, how big would nums be? K could be the entire array. So oopsies. Bro. 1, 3. Okay, so we can have a running total of the first K values, and then, right? Would that be fine? Because I know it's gonna be huge, so like making a copy of every subarray would be very expensive. Um, trying to think any caveats here. So like, okay, we'll have L and we'll have K here, right? But if I start like that, I have to compute that once, which is fine, I guess. So I guess we can compute it once. That's okay, right? So we can cur sum is, I guess, the first K values, right? So 0, 1, 2, 3, yeah, and then we'll do that, right? Sum of this. That should be okay, which could be the entire list, which could be kind of bad. Which is not that bad. No, it's fine, it's fine, it's fine. We'll have L for R in range of. We're gonna start to the next one. Okay, no, we're gonna start this one here. So we need to actually put this already in the list. So let's do that. Res.append cur sum. Wait. I need to know if this is a odd or even K. Damn. Okay, I forgot. This is not average. This is medium. So we actually get the middle value. Crap. Actually, wait. This is a little bit more complicated than I thought. Of course, the hard is not going to be that easy. This just sucks. This sucks. Okay, let me just put this. Ooh. Okay, this is kind of bad. Median is actually just median. Let's say K was 4, then we would have this situation here, right? We need to pull out the whiteboard, guys. This is gonna get very complicated. Let's do a simple number. Let's do like 1, 2, 3, 4. Let's do 5. Nah. Let's do. We'll say K is 2, right? K is 2, so we'll only be able to see these two, right? Right, and we'll only be able to see these two. Only able to see these two, and then we'll only be able to see these two, right? At a time, and we want to find the median for every subarray. Since these are even, we would have to tweak our logic here. So the even way, we just take left and right. That is the thing. We need to find the middle two values. Which means, oh, yes, wait a second. We can do like some kind of sliding. the problem is, how do I calculate median efficiently? Like, I was thinking of, okay, we're given our, if let's say the size is, even, right? Then we'll just keep going until they're like one apart, right? We'll like make some temporary integers and just kind of move the pointers till they're the middle two ones, which is basically when the difference between the two is exactly 1, right? Right? Then calculate, boom, right? But now if it's odd, we only care about the middle value. Now, how do we find the middle value? Is there a way to like make a running total, like as we go we build out till k size the median, right? The median of this is just 1. The median of this is 1 plus 3. The median of this is 3. Maybe I could have an m pointer, right? Like a middle pointer. Is that up? Oh my god. I see like a spider somewhere. It's like a shadow of a spider. I'm kind of scared. Okay, I'm getting distracted. Yeah, so what am I missing here, guys? Like this, like I guess we'll have like 3 pointers, right? We can have L, M, and R. R and M will be essentially kind of like at the same starting point, right? It will be like 0, 1, 2, right? Right? Like a triple pointer. So like we can do like we can move, we'll move this R, right, as we go. Let's say there's another element, 0, 1, 2, 3. Let's say there's another element here. We have another element here. We would have to increment Do you see the vision now? Where should M be now? M should be here. Okay, yep. Let's keep going. Right now we're at a odd number. Right? We're at an odd number. So we move it up. M should move up, right? And then now we're at another one. We'll move R up. Right? We should move. We can do R to calculate the middle 2 values. Ah, shit. Oh, we actually leave. No, we're getting too far apart. Or yeah, we can do m and m plus 1. That's exactly what it is. You guys see the vision? Like, as we only increment m when it's an odd situation, right? If the size of the list is odd, right? And we'll always have that thing. So that can help, right? This is now odd, which makes this here and makes know exactly the middle value. What is the purpose of L though? Is to shrink our kind of window. So yeah, I think I have to have 3 pointers here because I can't think of anything else that will help us like do anything. So if you do this here, right? Put this here. Then we'd have to move this. And then we and then we can move this we can move this here, right? And now we know exactly the middle value. But if, let's say, the window is here's the thing. We can calculate the middle instantly when it's odd. We don't need to have a middle pointer. But when it's even, that's our issue. So that's why I like having that middle pointer. Is because, you know. So basically, when our subarray is even, then we move M. If not, then we don't need it. That's weird though. That's kind of a weird solution. Like, if our window is always odd, okay, I guess we have essentially. Let's simplify it first. Let's just solve the odd case, because that's probably the easiest one. Right? We have the odd case where we will move. We'll start from K, or we'll start at K till length of nums. I assume we can go a little bit beyond, right? And right, basically, yeah, that's my problem. Where do we put M? How do we calculate M? Easy. Basically, 0 plus 3. So like, K, so what's it? R plus 0 plus 0, 1, 2, 3. So 3 plus L divided by 2. That will be our midpoint. Right? Right? Because let's look. 3 divided by size of the list. 3 divided by 2 is 1.5. And that's exactly what we just found out, right? R plus, so let's say 3 plus 0 is 3. So yeah, we get 1.5. So divided by, so we'll get 1 here. So that's our M. Nums M dot whereas the append nums n, right? Then we have to move we have to move them up a little bit, right? And move on. So this is the odd case. If length of if k mod 2 does not equal 0, yeah, so like if k mod 2 equals 0, then we would have to do a different approach. We'll have an end pointer, but it needs to start here, right? So let's say we have like for example L, M, and R. I guess it's okay to start at like next to L, right? Well, let's say it was like size like this right here, right? It's L 2, 3, 4, 5, 6, 7. So wait, 1, 2, 3, 4, 5, 6, 7. This is 8 elements, so this is the one with this is odd, right? Or this is even, so these are the two values. Let's do like 4 or something. Or let's do like let's say k is the entire thing. Like k is the entire size of the list, right? Then we would have k is 1, 2, 3, 4, 5, 6, 7, 8. So let's say k is 8, right? Right. So where should m be? Well, m should be right here. 0, 1, 2, 3. This is kind of I feel like there's some weird math trick involved with this. 0, 1, 2, 3. 1, 2, 3, 4. So we care about m and m plus 1. We take the average between those two, right? Or just like do this. Take the average, right? Right? Take the average, which will be, I don't know where it will land. So this is 8. 8 divided by 2 will be 4. So 0, 1, 2, 3, 4. So m minus 1. Will this work? I think I'm overcomplicating this. Let's say it was like size 2, right? There's 2 divided by 2. That's 1, 1. M and m plus 1. Or m and m minus 1. So m and m minus 1. Yeah. Okay. Then I actually think we only need 1, essentially. What do you guys think? What should I do? So I can do. I don't need like a current total, right? We can just have our boundary. Okay, so yeah, I just need one for loop. Right, so like we calculate, so we'll start from k, so it'll be 3, so we'll do this 0, 1, 2, 3. We'll have our calculation here. 3 plus L is 3 divided by 2 will be 1, so this will be the thing. So we just add that. Oh wait, what? It's 1? Wait, the median is 1? Wait, the median was 3. Huh? Why is it 1? Wait, I think I'm not understanding this problem. How is this 1? I mean, what? I'm confused. This is 6 because that's the middle. This is 5. Wait, what? I thought we get the median of the... Wait, I actually don't understand this problem now. That's so weird. Okay, I got it. Middle is the... Oh, I have to sort them because they're not in ordered list. Oh my god. And I'm not sorting every subarray, and that will be Thiele. In an ordered... I forgot you have to order them. Yes, you have to order them. Oh my god. Oh my god. Damn. Is there some trick with this? Like, I have to basically, at worst case, it's n, for every window, it's, you have to sort n log n. Jeez, this is gonna be hard. You're given an integer array nums and integer k. Oh my god. Damn, sliding window. That's why it's a freaking 38%. I might need a hint. We know that by definition a median is the center element. Wait, the simplest solution comes from the basic idea of finding the median given a set of numbers. We know that by definition a median is the center element. Given an unsorted list of numbers, how do we know how do we find the median element? If you know the answer to this question, we can extend this idea to yeah, how do we find the median in an unsorted list? Because I don't know if I'm supposed to sort. What is it? Is there a better way? Do you think there is some duplication of calculation being done here? Is there some sort of... Well, I don't know what you're talking about, bro. The third line is thought is also based on the same idea, but the achieving the result is differently. We always need the window to be sorted for us to be out there where we can use to obtain the median element extremely fast. We often need the window to be sorted for us to be able to find the median. Is there a data structure out there that we can use in one or more quantities to obtain the median element extremely fast? Damn. Is this really sliding window? A heap. I was thinking of a heap, but how would a heap be used? So like heapify every single subarray. Damn, this is harder than I thought. This is actually pretty hard. So is there a way to where we do the bit hand above? Do you think there's duplicate calculations being done? Is there some sort of optimization that we can do to achieve the same result? The approach is merely a modification of the basic approach, except to reduce the calculation of... The simplest solution comes from the basic idea of finding the median. Yeah, I don't know. I don't know how the heap can be used here. What is the... I might have to take the L here. Sorted list. 2 heaps. Let's see. What is a sorted list? I've never seen this data structure sorted. Is that just a sorted list? So we just go through it, add the number. If the length of the list is greater than k, then remove that number, I minus k. That's a weird solution. I don't really like this solution. I guess the heap is needed here. If the window size is not yet k, else if the k is even, the median is the average of 2 elements. Else, then just take the that's such a. I thought that wasn't gonna be. That was kind of cheeky to you. I see the vision now. It's just like as you build this, like as you build your kind of heap, I guess you have a like a heap that is like in the scope. Like okay, as you go here, oh we've hit k size, then we will take. I guess we can do some like math and get the middle value. I think that's what it's kind of saying. Basically, it's the middle value minus 1 and the middle value. Yeah, the exact middle value and the middle value minus 1. And you just add those and take the average. Otherwise, get the middle value. Remove calculations for the ith element. Shouldn't it be the jth calculate? I guess a sorted list. I would try this. I've never used a sorted list before, so sorted list. We'll call sorted list, right? So we have L, right, and then we will obviously just go to till length of nums, right? L. So if R minus L plus 1 is less or greater than K, or greater than or equal to K, right? I guess we can say equal to K because there's not really point of checking the greater than, right? Then we will check, okay, if K mod 2 is even, right? Right? Then res.append sorted, I guess sorted K divided by 2 plus K divided by 2 minus 1, right? And then take the average, right? Divided by 2 or divided by 2, right? Otherwise, right? Otherwise, res.append the middle value. I'm kind of disappointed in there's not much sliding windowedness here, to be honest. It is, but I've been pretty much overthinking a lot of it, and then we removed the current one, I guess. Right. So and also increment. Yeah. Okay, let's try. Oh, wait. Oh, wait. We should probably put this here because we want to move on. If it's... No. We want to... Yeah, we want to remove L. I don't know why I'm removing R. This doesn't really make sense to me. L. And we increase it. Yeah, that makes more sense. I thought that was gonna be bad, but I forgot about the sorted. That was kind of my dumbness. Okay, now I'm kind of having an issue with oh wait, I'm not adding. I should be adding add nums of R. This is such an easy solution, bro. I had the idea, I just forgot about the sorted properly. Like it's so dumb of me. Yeah, it's just so dumb, bro. Yeah, this is a sliding window-esque, but you know. Anyways, this passes. Thanks for watching. I'll see you guys tomorrow. Peace.